Welcome to the second section of our course, the section addressing the ISO OSI model, the very famous 7 layers. This section is demonstrating these 7 layers and their functionalities. The ISO OSI model, as we can see, is an output of the ISO, International Standardization Organization. This output is named the OSI model, Open System Interconnection Model. It's a primary architectural model for networks. It was developed in 1983. It's only a group of concepts. This means that the model does not specify a certain hardware or software to exist. It is a group of concepts. It's a conceptual model that specifies the functionalities that are needed to be done to transmit data from a certain source to a certain destination over the internet. It specifies how data can be sent or received either hop to hop, which means either from the machine to the switch to the router and so forth, step by step, or sending and receiving data end-to-end, which means sending and receiving data between a source that is in Malaysia and a destination that is in Egypt, which means that both are trying to send correct data, reliable data from a certain source on the internet to a certain destination over the internet worldwide. The benefits of dividing this model into layers are a lot. Dividing the network communication process into layers allows for easier troubleshooting, allows for easier design, and easier specification for each layer to be set inside this model. It allows for multiple vendors to build their products, either software or hardware products, based on the same standard model that is called the OSI. Many vendors, giant companies, can establish hardware components or software components based on this ISO OSI model, and these components can interact and can send and receive data to each other since they are based on the same model, the OSI model, the Open System Interconnection Model, designed by the ISO, International Standardization Organization. Various types of networks with various types of hardware and software can communicate, which means, for example, that Windows machines can communicate with Linux machines. IBM machines can communicate with Apple machines. Machines on copper cables can communicate with machines on fiber optic cables. All of these, since based on the same model, can communicate with each other and can send and transmit data with each other built on the same standard model, that is the OSI model developed by the ISO. The layer separation makes it easier to change the design of one layer without affecting the other layers, without affecting the upper or the lower layer. The design, the functionality of each layer can be made better, can be changed without affecting the 7 layers as a whole. We just take into consideration what each layer can take from the upper and deliver to the lower when changing the design of this layer. Layers interact with each other. While sending, each layer passes the data downwards from the 7th to the 1st. While receiving, data is passed upwards from the 1st to the 7th. And the headers of each layer is added while you are sending, and it is removed while you are receiving. This is the interaction with the layers that allows and that gives us at the end better communication between hosts and destinations over the internet. This is the diagram showing the 7 layers. We should know by heart these names, and we should know by heart that we are counting from bottom to up. The first layer is the physical. It's always layer number 1. The second is the data link. The third is the network. The fourth is the transport. The fifth is the session. The sixth is the presentation, and the seventh is the application layer. We always count from down to up. Each layer is summarized in one sentence in this slide. The application is responsible for communication between the application itself as a software and the network processes lying in the layers down. The presentation is responsible of data representation. The session is responsible for managing the session in the inter-host communication process, starting, ending, and managing the session while communication. The transport is responsible of end-to-end connections, either reliable or best effort delivery. The network is responsible for addressing and routing, finding the best path for the data to go through based on the address of each machine. The data link is responsible for accessing the media and avoiding collisions. The physical is responsible for the binary transmission of ones and zeros, representing the data in electrical form or in light form if we are going to use the fiber optic cables. Network protocols that were based upon the ISOOSI model are a lot, but we are here focusing on 4 protocols that were used and were common and were extensively known to be protocols based on the ISOOSI model. The NetBEWI protocol, the IPX-SPX protocol, the AppleTalk protocol, and we end by the TCPIP protocol, the standard protocol of the Internet that will be addressed the next section in details. The NetBEWI protocol, NetBEWI stands for NetBIOS Extended User Interface. It was a LAN protocol that work only over LAN and do not work over wide area networks. It has limited performance, not a good performance, and it's now almost obsolete protocol. It does not exist a lot or not common to be existing over the world. But this was a LAN protocol based on the ISOOSI model. The second protocol is the IPX-SPX that was vendor-oriented, that was designed by one of the companies working in hardware and software. It was standard based on the ISOOSI and it supported transmission of data over WAN. But it also had a disadvantage, a drawback, that it was oriented too much towards its vendor. It had poor performance if used with other vendors. If you use this protocol with another vendor, not with the vendor that made this protocol and designed it, you will have a very poor performance on your network and your machines. AppleTalk is a standard protocol based on the ISOOSI. It supports WAN and it supports data transmission over routers, but it is very oriented towards its vendor, and it also has the same drawback and the same disadvantage of poor performance if used with other vendors. It worked greatly with the same vendor that made this protocol and made the machines using it, but it had a very poor performance if you changed the machines to be made with other vendor using this protocol. The TCPIP, the word TCPIP stands for Transmission Control Protocol Internet Protocol. It's a standard protocol. It supports WAN and supports to be transmitting data over routers. It is not vendor oriented, and this is a very big advantage in TCP/IP that makes it growing and developed and always the standard protocol for transmission over the internet. Nowadays, the TCP/IP is the most widely used protocol over the internet. The TCP/IP is completely and entirely mapped to the OSI layers. The OSI 7 layers are completely mapped to the TCP/IP protocols, as you can see in this diagram. It is not a one-to-one mapping. It's a group-to-one mapping between the OSI layers and the TCP/IP protocol. Now we had a good idea about the ISOOSI model in this lecture. Thank you.